It was the most famous eruption on Earth. The force was thousands of times more powerful than the atomic bomb that destroyed Hiroshima.
It was an absolutely huge explosion.
And the island essentially disappeared.
The biggest blast in history.
It was probably the largest sound ever heard on the Earth.
If you were within earshot of the volcano, you were dead, essentially.
The explosion triggered 10-story tall tsunamis that hurtled giant rivers of molten lava toward land.
It killed almost 40,000 people along the shores of West Java and Sumatra.
In the century since, a dangerous new volcano has emerged from the fiery abyss. A major eruption today could be cataclysmic.
You'd be dealing with hundreds of thousands, if not millions, of casualties.
And scientists fear this sleeping monster could soon reawaken. Krakatau's Revenge on Mega Disasters. One day soon, one of the world's biggest volcanoes could suddenly erupt. If so, it would be a worldwide catastrophe. And it would be a reprise of one of the most spectacular natural disasters in history. Ground Zero was a group of volcanic islands that lies halfway between Asia and Australia in present-day Indonesia. They were situated in a narrow passageway called the Sunda Strait, between the two main islands of Java and Sumatra. Today, the island chain is called Krakatau, but history remembers it as Krakatoa.
Krakatoa suddenly annihilated itself, an enormous explosion, basically.
You are left with a large hole in the seafloor, an island, 2/3 gone, vanished.
It was a global event, it was an exotic event, and it was a big event.
In 1883, Krakatoa was 3 times its present size, at 2.5 miles long and 5.6 miles wide. It had 3 large volcanic vents, or cones. The largest was called Rakata. In the middle was the Danan cone, and at the far end, Perbuatan. Experts agree that the location of Krakatoa is the primary reason that to this day, it is one of the most dangerous volcanoes on Earth. It lies in the center of Indonesia's volatile volcanic arc.
The Indonesian volcanic arc is one of the most active in the world. There's about 130 volcanoes spread over about 700 miles.
The volcanic arc stretches the length of Indonesia and into the Pacific along the edge of 2 ever-shifting continental plates.
One of the great tectonic plates of the Earth is pushing underneath another of the great tectonic plates. And where those one plate pushes underneath the other, you get volcanoes formed.
This geophysical process is known as subduction.
The reason you get volcanoes is really quite simple. The floor of the ocean on one of the tectonic plates is soaked in water, the rocks are wet. And when those wet rocks are pushed perhaps 100, 150 kilometers deep into the Earth, that water makes the hot rocks in the Earth's interior melt. And those melts then come up, they rise up and they form volcanoes. Very big eruptions are fairly frequent in that part of the world.
Some of the biggest volcanoes on Earth are situated in this hazardous region, including Toba and Tambora, which last erupted in 1815. Fortunately, both these mighty mountains were located in remote and sparsely populated areas. That was not the case with Krakatoa. The famous volcano lay only 30 miles from the coasts of Java and Sumatra. In 1883, about 500,000 people lived there. Java was a thriving Dutch colony and the hub of an international trade route that took goods, mainly spices, from Asia to the Americas and Europe.
Well, the Dutch had an enormous trading empire based in Batavia, which is modern-day Jakarta. To this day, there's a trading company in Holland which uses an Indonesian island to produce the nutmeg that goes exclusively into Coca-Cola.
Residents of Java were oblivious to the danger they were about to encounter. Krakatoa at the time was thought to be dormant. In fact, centuries had passed since the last known eruption.
Well, before the eruption in 1883, there must have been a large amount of molten rock in what we call a magma chamber, several miles underneath the volcano.
This magma body sits there as a pool of partly molten to molten material, gradually growing as new magmas fed in the bottom, usually because of the strength of the rocks or over it, or that it's got a thick, already crystallized and sort of solid cap to the magma.
The first clue of the impending mega disaster came on May 9, 1883, when an earthquake was reported by a lighthouse keeper. He was at the First Point Lighthouse on the west end of Java, approximately 45 miles south-southwest of the volcano.
He felt, in the middle of the night, the ground shake. And then there was a brief, what he called an earthquake in the air. It was as if a brief sort of wind occurred, which knocked him backward briefly.
People living along the coast didn't know it yet, but they were within range of the stirring volcano and were in mortal danger.
Nobody realized it was a volcano. It started rumbling, and fishermen who used to go out there to fish started saying that there was boiling water and bad smells, and it just got progressively worse during the year.
After the first movements in May, it would take Krakatoa months to build enough force to violently explode.
It's quite likely that some very hot molten magma from even deeper in the earth started to rise up underneath the volcano and actually came into this magma chamber. And this magma chamber then increased in pressure, and this started to force the rocks apart.
Despite the subterranean maelstrom, residents of Batavia, 90 miles away, were unperturbed.
There was a wonderful letter from a woman saying that she loved going to hear Bach cantatas being played in the town hall in Batavia, but she couldn't hear them clearly because the volcano was making such a noise that it rattled all the windows and spoiled the concert. So it wasn't a danger, but it was a nuisance.
By August 26th, after weeks and months of explosions and ejections, Krakatoa was ready to rip.
When that molten rock forces its way close to the Earth's surface, it's like taking a cap off a fizzy drink. The pressure goes down and the gas forms bubbles, but forms bubbles very violently so that the magma essentially explodes itself.
Just after 1 p.m., the volcano let out an almighty bang. A thick column of black smoke, steam, ash, and debris shot 17 miles, more than twice the height of Everest, into the sky.
But no one gave any thought to the idea that this was merely the precursor to something truly massive.
Krakatoa had just entered what scientists call the cataclysmic eruption phase. The big one was about to hit. On the morning of August 27, 1883, the sky was filled with smoke for 40 or more miles around Krakatoa. A cloud of ash blanketed the Sunda Strait, and the sun was barely visible.
Well, people woke up on that morning to a continuation of the kind of erupting activity that had characterized the Sunday. Large columns of black smoke, deafening noise, lots of flame, lots of fire.
Krakatoa had entered its death throes.
There probably were substantial evacuations because people were scared about the volcano. But they'd also sort of been seduced into staying because the eruption grew slowly.
Tens of thousands of people had not heeded the warnings and were now in the line of fire.
This eruption is slowly getting worse and worse and worse, but they're always reluctant to leave. And then the bad thing happens and now it's too late.
The eruption culminated that morning in a series of huge, very loud and cataclysmic explosions.
When there's a particularly vigorous explosion or a particularly vigorous pulse of magma, then it sends a great cloud up in the atmosphere. And as that cloud gets into the higher levels of the atmosphere, it becomes supersonic and it generates an explosive noise.
The first megablast was recorded by chance at the Batavia Gas Works, 90 miles to the east. It appeared as a pressure spike on their barometer at precisely 5:30 a.m. A massive column of volcanic ash, rocks, and pumice shot 20 miles into the sky.
The volcano started to fall apart. All this shaking and rumbling and blasts of ash going up in the sky. In doing so, it opened up cracks and channels for which the water then moved into the vent of the volcano and came in contact with the magma as it was being erupted. So everything got amplified.
Another larger explosion hit at precisely 6:42 a.m. Then another an hour and 38 minutes later.
Volcanoes that have this type of behavior often are compared to many nuclear bombs exploding all at once. That's their power.
At exactly 10:02 a.m., the biggest explosion of all struck.
The sound was undeniably the loudest noise ever generated on the surface of this planet, at least since humankind has been around to hear it. Sailors that were maybe 10 miles away, they took the full brunt of it, and nearly all of them had their eardrums punctured and went deaf.
The sound of the fourth explosion traveled a radius of about 3,000 miles.
It was as if there was an enormous explosion in New York, which was heard with perfect clarity over in San Francisco. An unimaginable thought, but Krakatoa was that big.
The biggest explosion ever heard on Earth was measured 100 miles away to be a record-shattering 180 decibels. Ash from the explosions fell on Singapore, more than 500 miles to the north, and on the Cocos Islands, more than 700 miles to the southwest.
At the same time, through these explosions, there is an enormous push into the atmosphere. It's the atmospheric tsunami. This is the example of this pressure wave that then goes out, and it actually traveled around the world several times.
The massive blast blew dust, debris, and molten rocks more than 20 miles into the stratosphere.
Once the eruption was really going full bore, you have this immense amount of material that's basically suspended dynamically in the air and forms a big cloud up at about 30,000 feet or so.
Part of the eruption column is simply too heavy to be taken up into the atmosphere, and it falls out, it sort of cascades out like a fountain collapsing, and ash and hot gases flow down the outside of the eruption column, down the outside of the volcano, and hit the sea.
When the pyroclastic flows enter the water, they're like very rapidly moving avalanches. They push the water away, and these can create waves, which essentially are tsunamis.
It's kind of traveling like on a superheated cushion. Water is vaporized at the interface and kind of lifts the lighter part of the pyroclastic flow across the surface.
An estimated 4,500 were killed by pyroclastic flows alone. Experts agree they probably perished in seconds.
People are almost instantly incinerated if a pyroclastic flow hits them.
It truly is biblical. Out of nowhere comes these massive great waves, and no one really knows what's going on. Just completely terrifying.
We cook meat in our ovens at somewhere between 150 and 250 degrees centigrade, and we're talking about pyroclastic flows being 600 or 700 degrees centigrade.
The first giant volcanic wave hit the southern Sumatran town of Teluk Betung. 5,000 were killed in seconds.
It's in the order of 60 to 200 miles an hour. So you're not going to be able to run away.
Water would just come marching in and completely unstoppable.
Each massive Krakatoa explosion triggered bigger and bigger waves. Some were said to be over 100 feet tall.
There were lighthouses where there were concrete harbours, all of them wrecked. A huge masonry lighthouse, 150 feet tall, just ripped off its foundation. Locomotives weighing scores of tons being just tossed off the lines and smashed into the ocean.
The tsunami tossed a steamship miles inshore.
The boat was made of iron. It was picked up by this wave, taken deep into Sumatra. It went 2.5 miles up a river valley, then was crashed down onto the jungle floor, killing everybody in it.
The waves push inland, float everything ahead of them, drown people, and then suck everything back out to sea again. This happened 4 or 5 times with major tsunami hitting Java and Sumatra.
The waves would have been 5 or 6 minutes apart. So you can imagine a wave that is, say, 10 meters high, and the next one is 5 minutes after that.
10,000 died in the Javan towns of Merak and Caringin.
The local Dutch official reported all sorts of terrible things happening, and the unimaginable power of the water just tumbling people like an avalanche.
The Krakatoa eruption had a stunning finale. A fifth enormous explosion came at 10:55 a.m. In a complex chain of geophysical events, known as a caldera collapse, Krakatoa's 3 cones caved in and fell into the chamber vacated by the once erupting magma.
The island essentially disappeared, and for a few seconds there was an almighty crater torn in the sea.
2/3 of the island collapsed, slid into the ocean, and triggered more killer waves. Less than 2 hours after the final explosion, a wall of black water hit Batavia on the mainland of Java, 90 miles away. The giant wave had lost much of its awesome height and power, but still caused chaos and deadly destruction in the city, and dozens died.
These waves continued far out. They went through the Indian Ocean. They made it around South Africa and were even measured all the way up into the North Atlantic and into Liverpool.
When Krakatoa was done erupting, the toll could be counted. Some 165 Indonesian coastal villages and towns were devastated, and at least 36,000 people were killed.
Every village on either side was destroyed.
The news of the cataclysmic eruption of Krakatoa and the catastrophe it caused shocked the whole world.
It was the first large disaster that took place after telegraphs had been invented. And so instantly, within a day, everybody around the world knew about it.
It was the modern world's first big disaster in that it was the first public disaster. And the deaths were so high, 36,000 people dead, an unimaginable number.
The global impact of the modern world's first mega-disaster had just begun.
A few months later, red and yellow skies appeared around the world. In London, there was this beautiful volcanic sunset that appeared. They said, this came from the other side of the world, and they could actually see with their eyes at sunset the effect of this eruption.
The vast volcanic clouds laced with sulfuric acid caused startling atmospheric aberrations across the planet. A pale green moon was seen in Madras, India, more than 2,000 miles away on September 12, 1883. Sunglows were reported in Yuma, Arizona in October.
When the sun sets and then goes over the horizon, there's a reflection of the sunlight at these layers, these aerosol layers. And this is this intense red light.
But since then, scientists from all over the world have sifted through the ruins and the remains of Krakatoa, as well as the historical records to find clues as to what happened and why. What they discovered about the modern world's first mega-disaster changed science forever.
A whole number of sciences made big leaps because they could associate the phenomena that were observed in the sea, in the atmosphere and on land with an actual volcanic event. This is the map of where the pumice was found, taking as little as a month to actually cross the Indian Ocean and reach the African coast.
Recent discoveries of telltale volcanic deposits in the ice cores of Greenland and Antarctica have led some researchers to a surprising conclusion. As bad as the 1883 eruption was, there was a much larger eruption 1,300 years earlier.
It was an absolutely huge explosion, certainly one of the largest volcanic eruptions in the past 50,000 years.
If David Keyes is right, and there was a 535 AD super eruption of Krakatoa, it means it could happen again. But this time, it would cause a catastrophe that could threaten civilization itself. London's Royal Society Academy for Science holds a vast collection of information about the 1883 eruption of Krakatoa.
Airwaves made the gasometer pulsate.
While scientists know how the volcanic island known the world over as Krakatoa was created,
This shows an etching of the spectacular photographs they've got of the eruption.
why it erupted in 1883 and with the force it did was a mystery for nearly a century.
The activity seemed to go on for about nearly 12 hours.
That's right.
In 1979, Stephen Self and colleague Michael Rampino embarked on a field expedition to Krakatoa. They found geological evidence that would explain the mystery of Krakatoa.
We visited all the islands and collected samples and made sections of the ash deposits, the pyroclastic deposits from 1883, and pieced together an interpretation of the eruption.
Self quickly surmised that Krakatoa is a classic example of the most dangerous type of volcano, a caldera, the Spanish name for cauldron. A caldera is basically an immense crater, a bowl-shaped indentation left by the biggest previous eruption. It also is an indication of the potential size of a future eruption. The area formed by the caldera outlines the shape and size of the magma chamber that lies beneath a volcano. The larger the caldera, the more magma that can collect below. The caldera left by the 1883 Krakatoa eruption was estimated to be a huge 4.5 miles wide. There is geological evidence to indicate that the 1883 eruption was not the first massive eruption of this most dangerous volcano. That eruption was the result of over 1 million years of volcanic activity. The first human record of an eruption of Krakatoa is found in the Javanese Book of Kings. This sacred Indonesian text describes a massive explosion in the Sunda Straits in 416 AD. According to this account, it split the mainland into the two islands of Java and Sumatra. To date, however, geologists have found no physical evidence of a huge eruption of Krakatoa in 416 AD. But some researchers claim to have found geological clues indicating a massive eruption in 535 AD. 119 years later. They believe that the ancient text in the Book of Kings was referring to the 535 AD eruption.
The entire event was the equivalent in terms of energy of many hundreds of millions of Hiroshima bombs. A magma fountain would have shot something like 30 miles into the air. 25 cubic miles of tiny ice crystals which then spread out and began to reflect sunlight back into space, thus cooling the whole of the planet.
Based upon 6th century literary accounts from all over the world, Keyes surmised that this super eruption occurred around 535 AD.
We knew from historical accounts that there had been a major climatic problem at that stage in the middle of the 6th century. We knew especially that the sun had literally been partially blotted out.
A 6th century European historian wrote that the sun became dark and its darkness lasted 18 months. Keyes believes that this super eruption of Krakatoa triggered a global climatic disaster that led to famine, war, and plague.
Initially, crops failed. There was competition for resources because of shortage of food and a lot of warfare, and that in turn led to a lot of disease. And there's then a huge pandemic of plague, which actually, without doubt, killed more people than the actual eruption itself.
At the Los Alamos National Laboratory in New Mexico, volcanologist Ken Wolitz searched for scientific evidence to support the 535 AD supereruption theory.
David Keyes has put together quite a bit of data consisting of tree rings, ice core, lake deposits from all over the world.
The smoking gun lay literally in the ice cores of Greenland and Antarctica. Earth scientists call it the archive. Like the rings of a tree, each layer of ice corresponds to the year it was deposited. Careful analysis has allowed scientists to date each layer in the archive. The deeper the layer, the older the deposit.
Volcanoes typically show up where there's a concentration of sulfuric acid, and essentially where there's a large eruption, we count the layers and we know what date it occurred. So there was acid signature at 535 AD, and this was found in the grip ice core of Greenland.
They also found an acid signature in the ice cores from Antarctica.
So what this means is if there was a volcano, it probably had to occur on the equator in order to spread sulfuric acid droplets both north and south.
The scientific evidence and the historical records confirm their belief that a supereruption occurred somewhere along Indonesia's volcanic arc. They now needed to find a volcano with a caldera large enough to produce a supereruption.
We began a long hunt for some sort of cause, and that ended up as finding a likely culprit being a volcano right smack dab where Krakatoa is now located.
Examining underwater charts, Wolitz saw a 30-mile wide caldera. Using all the data collected, Wolitz created a Krakatoa supereruption model to visualize his assessments.
A column of ash and pumice rises over 50 kilometers up into the stratosphere.
Until scientists can find definitive geological evidence, the theory that Krakatoa had a supereruption in the 6th century is still just conjecture. The research by Keyes and Wolitz, however, does show that such an eruption of Krakatoa would have the potential to cause a worldwide catastrophe.
This situation would lead to devastating effects on agriculture, climate, and so if one happened now, there's no doubt it would be a very serious global event.
For decades after the 1883 mega-disaster, the world believed that Krakatoa would once again sleep for thousands of years. But then, on January 26, 1928, a small volcanic mound emerged from the sea, where Krakatoa once stood. The most deadly and dangerous volcano on Earth was back. On June 29, 1927, Indonesian fishermen were sailing between the three islands left by the fearsome 1883 eruption of Krakatoa. They were trolling the fertile waters around this most famous volcano when they noticed gas bubbles rising from the sea.
Suddenly, out of the sea itself came a huge eruption of smoke and steam and flames. And the idea of flames coming out of the sea is sort of hellish. This went on for quite a while. The eruption stopped and there was a thin cusp of black land above the surface of the water. It was washed away by the waves and the currents.
Within 6 months, an island measuring 10 feet high and 600 feet long had appeared above the water.
Obviously a new volcano had been growing on the seafloor and had taken that long from 1883 to the 1920s to become first emergent and then established itself as a permanent island in 1929. And since then it's erupted regularly, it's grown, and it now occupies a good chunk of the caldera floor.
In the intervening years, volcanologists, mindful of its violent past, have closely monitored the growth of the new island that the locals call Anak Krakatau, or Son of Krakatoa. Quiet periods have been punctuated with occasional large explosions and eruptions. Fresh and steady lava flows have contributed to the relentless growth of the new volcano, adding 25 feet to its height every year.
I think once Anak Krakatoa had established itself, it was an ominous reminder of what had happened in 1883, that here it was all going to start all over again.
Anak Krakatau today is 600 feet tall and is more than a mile across. Experts reason that a massive eruption of Anak Krakatau is only a matter of time.
This is the new Krakatoa. If ever there's another event, it will occur in and around this extremely dangerous little volcano.
Today, the islands of Java and Sumatra, ground zero of an impending mega-disaster, are the most densely populated islands in the world. An estimated 2 million people are within striking distance of Anak Krakatau.
If the same thing were to happen again without any warning and without any knowledge of the previous eruption, then that 36,000 would probably equate to a couple of 100,000.
To try to limit the death and destruction of the next eruption, volcanologists, oceanographers, and climatologists all over the world are conducting a myriad of experiments to try and understand what would happen if Anak Krakatau were to erupt. They hope the answers they find will help them predict and possibly prevent the next mega-disaster. At the O.H. Hinsdale Wave Research Laboratory at Oregon State University, tsunami expert Hermann Fritz is conducting a unique experiment to evaluate the potential destruction a new eruption at Krakatoa could cause.
Well, this is the only tsunami wave basin in the world that's just designed to study tsunamis, and it's also the largest tsunami wave basin in the world. So it gives us the opportunity to study tsunamis at a very large scale in a laboratory.
Fritz believes that this scale model experiment will replicate exactly what happened in the 1883 eruption of Krakatoa.
In this wave pool, we've set up a landslide tsunami generator, which you can see behind me. Gravel. We're going to be filling the landslide tsunami generator with rock mass of gravel, which is going to mimic the collapsing volcanic island.
They carefully load the landslide generator with nearly 1.5 tons of gravel. This experiment is a 1/30th scale model of the 1883 eruption. The pool is about 5 feet deep, representing the 150-foot depth of seawater in the Sunda Strait. Cameras and computers track the impact and the waves generated by the volcano's collapse.
We have multiple crosses on here which we use to calibrate our high-resolution cameras to get the run-up on the hill slope. And we throw little small particles as tracers onto the water surface so that we can get the motion on the water surface, the circulation on the water surface. Full load right there.
They launch the landslide generator.
Wong,
Yeah, I'm ready.
Doc, are you ready?
Yeah, I'm ready.
Everybody start to read your cameras. I'm going to fire now.
They repeat the experiment dozens of times to quantify the results. A giant wave wipes out the closest island, destroying all structures, washing away anyone or thing living on it.
We can see the landslide, collapsing volcano come down the hill slope and hitting the seafloor and thereby generating the tsunami wave.
A wave equivalent to a 100-foot tsunami smashes into the shores that represent Java and Sumatra. The experiment confirms their computer tsunami models, and the scientists come to a chilling conclusion. If a major eruption of Anak Krakatau were to happen today, 10-story killer tsunamis would hit the Indonesian shore before an official warning could alert the citizens.
One can try to reduce the amount of casualties, and that can be done dramatically by educating people. In locally generated events where there's very little time, where there's less than an hour warning time, in some cases a few tens of minutes.
The first official early warning of an impending tsunami will come from the Pacific Tsunami Warning Center, 6,000 miles away in Honolulu, Hawaii.
Our initial information for a big earthquake or even an eruption is seismic. Unless you have sensors right there close to the volcano, you really don't know what's going on. If it took us 15 minutes, for example, to warn people in the Sunda Straits about Krakatau, well, that doesn't do any good. Our warning is issued to people who are already dead.
As history and science have shown, the devastating impact of a huge eruption would not be limited to the Sunda Strait. If Anak Krakatau produced a super eruption, a giant ash cloud would shroud the entire planet, and that would herald a global catastrophe. At the National Center for Atmospheric Research in Boulder, Colorado, Kaspar Arman studies the climatic effects of volcanic eruptions.
We look at climatic impacts of these volcanic eruptions in the past, but also in the present, that we can use for predictions of what climate response would be if a very large tropical eruption would happen today.
In recent studies, Arman and his fellow scientists have focused on the worst-case scenario, that of a super eruption of Anak Krakatau and its potential effect on the ecosystem.
What we did in a study is essentially take the Krakatau mass and we multiplied it by a factor 100 and then ran with a climate model where we have a dynamic vegetation built into this model, so we could simulate how vegetation around the world would respond.
The global impact is dramatic.
The radiation in blue, it shows how immediately we cut off a large amount of energy and the temperature lagging behind a little bit, dropping by about 10 degrees Celsius, almost 11 degrees.
According to this model, the worldwide chill caused by a super eruption would last for decades.
When we look at vegetation, we see that the boreal forests in many areas completely collapses and disappears.
Agricultural production will go down to essentially zero, and we would have to think that this would be sustained for several years. It's very hard to imagine how we would deal with something like that.
Next, using computer models by the world's preeminent oceanographers, volcanologists, and climatologists, we will experience the awesome super eruption of Anak Krakatau, the son of Krakatoa. Today, a dangerously active volcano called Anak Krakatau stands on the site once occupied by the most famous volcano on Earth, Krakatoa. When it erupted in 1883, Krakatoa sparked the modern world's first mega disaster. It resulted in more than 36,000 dead and destroyed hundreds of towns and villages all along the coasts of Java and Sumatra in modern-day Indonesia. If a massive eruption happened today, 2 million people living along those same coasts could face annihilation.
It would probably proceed initially like Krakatoa proceeded in 1883. There would be ground shaking. There would be ominous rumblings. There would be an emission of steam and gas and ash.
The earthquake is the first sign of the impending global mega-disaster. High tides are reported in Jakarta and along the Java coast. Unfortunately, earthquakes are a part of life in Indonesia, and most locals decide to ride it out.
With any luck, the Indonesian authorities, who are well versed in volcanoes, would urge the people to leave, but people don't leave.
The next morning, a huge explosion rocks Anak Krakatau. Dust and debris shoot 20 miles high. A pyroclastic flow triggers a tsunami wave that hurtles toward the shores of Java and Sumatra at 60 miles an hour.
It's just like a torrent of fire coming at hundreds of miles towards you would destroy everything in its path.
If you're too close, you wouldn't live. It's beyond comprehension.
As witnessed in the 2004 Indonesian tsunami, thousands will try to flee from the many densely populated towns along the shores of Java and Sumatra.
Indonesian roads are usually not wide open, and there are not many lanes usually, and traffic jams up very quickly. You're going to have to make it a couple of kilometers inland in a few tens of minutes.
Less than an hour later, a second huge explosion follows. 600-ton boulders and lumps of pumice land on shore, possibly killing those attempting to flee the tsunami and the pyroclastic flows speeding to shore.
All the towns will pretty much be hit along the Sunda Straits, both in Java and in Sumatra.
Tens of thousands could die, be crushed, and swept away.
This huge mass of superheated air and fire and rock would just roll over the town, setting everything on fire, killing everyone within seconds.
Then a third massive explosion rips the whole island of Anak Krakatau apart. The vents collapse into the emptied magma chamber below. This massive eruption displaces all the water in the Sunda Strait. It generates a wall of water 100 feet tall.
Fortunately, we're limited by physics. The tsunami from a mega eruption really wouldn't be all that much worse than the tsunami of 1883.
At the same time, a mammoth column of ash, rock, and volcanic debris shoots 30 miles high into the stratosphere, creating an enormous cloud of ash.
And the ash clouds can blow many thousands of miles away with the winds before the ash falls out.
In a super eruption, anything closer than about 100 kilometers from the volcano is going to get completely devastated and then buried by hot volcanic ashes.
Where the ash lands, buildings collapse under the weight. If it rains, the ash gets heavier and more buildings collapse.
The engines of any airplane flying within 100 miles of the eruption would seize in midair.
The engines would be ruined. You couldn't fly in that part of the world.
In the first few days, 100,000 people could easily perish in Indonesia. Those who survived the initial mega disaster would be forced to abandon their cities and their homes. Millions could be displaced within hours of the super eruption. But the global catastrophe has just begun, as a giant ash cloud shrouds the entire planet.
The cloud would start to spread, and within a month it would start to get dark and dark and cold.
In London and in Washington, D.C., it will turn day into perpetual night.
Surface temperatures start to fall. You might have average temperatures that plummet by as much as 10, 20 degrees.
The effects are global-wide and are massive. Vegetation responds immediately. You lose vegetation.
The major concern, however, would be your food supply. And once food runs out, what are you going to do? It would be massive panic, and it would be a horrible disaster. I mean, most people would die from starvation.
The consequences of a super volcanic eruption would be catastrophic. Millions could die, and the environmental damage could last for years.
The statistical chance of there being one in the next 10 years is extremely small, or the next 100 years is extremely small. But there's always a very small statistical chance that one could occur.
Most scientists agree that it will likely take thousands of years for Anak Krakatau to build up enough volume of repressed magma to generate a super eruption. But an eruption the size of the one that destroyed Krakatoa in 1883 is still a terrifying possibility.
The volcano will erupt again. It's just a question of when.
There's no doubt it would be a very serious global event.
That would be a catastrophe of unbelievable dimensions.
We'll survive, but the world will look very different, perhaps.